Today's class is going to be spent working on some questions involving multiple forces, just like we did yesterday. But some of the problems won't be the same as we did yesterday. Same basic idea of F net is equal to the sum of the forces, but not the exact same context. Okay, what we did yesterday with those multi-force problems was elevator type problems. Okay, they weren't all literally elevators, guys standing in an elevator, what's the force of the floor pushing up on them? Maybe we had a situation like question number 2 here, where it was an engine being pulled up, but it was like an elevator. It was an elevator, or it was like an elevator. Today we're going to do some of those, but we're going to do some more stuff as well involving multiple forces. First, we'll do question number 1 and 2, which are our homework questions on page 152. Question number 1 says the person in example 3.7 rides the same elevator. And I think what you needed from that was the mass of the person, right? The mass of the person in the elevator, I believe, was 600 kilograms. Is that right? The elevator cable exerts a force of 5.2 times 10 to the 3 newtons upwards. Find the acceleration of the person. And if you're not sure what to do with a force problem, okay, ask yourself one question first. Is there one force acting on this problem, or is there more than one force acting? Hey, if there's one force, it's just a problem like F equals ma, maybe Vf squared is equal to Vi squared plus 2AD, something like that. If there's more than one force acting, you have got to draw a free body diagram. So here's the free body diagram, because we know we have more than one force acting here. There is acting on this person and the elevator that have a mass of 600 kilograms. There are two forces. What are those forces that are acting here? Tyson, what's one of them? Gravity. Good. Gravity acts downwards. We don't know what its value is, do we? We could find it pretty easily, I think, actually, but we don't know what it is right now. What's the other force acting? Totus, look at question number 1. What's the other force acting on this elevator? Yes, the force of the cable pulling up. We can call that the normal force, Fn. We can call it Fc if you want, call it Fa if you want, call it F1 if you want. It doesn't really matter. I'm going to call it Fn because that makes it a little bit more like the true elevator problem that we saw yesterday with the normal force acting up on the guy, right? Now, the normal force, we know what its value is. The cable, the normal force pulling up with 5.20 times 10 to the 3 newtons. All right? Guys, unless this is a free body diagram of a rocket, this is not rocket science. Okay, if it is a free body diagram of a rocket, then it actually is rocket science. But it doesn't mean it's really any harder. Okay, it just means that it's a slightly different context. We know how to deal with different contexts, right? Okay, we've dealt with elevator problems. Now we're dealing with another elevator problem. It's the same context, but even if it is a different context, we can deal with it. Look, we got two forces acting. What do we do every time, regardless of whether it's an elevator or a rocket or whatever the case may be? Next step is always the same, always. Stephen, what is it? What's the next step? Once we got a free body diagram, we always do the same thing. Good. The net force is equal to the sum of the forces. Add up all the forces. Don't worry about numbers. Don't worry about directions. Don't worry about signs. Just add up the variables or the symbols for the variables. F net is equal to the sum of the forces. What's F net also equal to, Kenway? Good. M times A, the mass times acceleration. So let's fill in Fn plus Fg again. And now let's start plugging some numbers in. We know what the mass is here. It's 600 kilograms. We don't know what the acceleration is. That's what we're trying to find. Fn, do we know what Fn is? Elena, do we know what the normal force is? Okay. That's okay. That's okay. Nick? Good. 5.20 times 10 to the 3 newtons. What about the force of gravity? Cassie, do we know what the force of gravity is? Almost. It's not 9.81. That's the acceleration of gravity. The force of gravity is? Okay, getting a little bit closer. We're still missing one little thing in there. No, before that, actually. Sabina? Good. 600 mass times 9.81, right? Now, you're right, we got to make it negative. Whether we make it negative out here or right here doesn't really matter. Okay? But it's got to be negative, you're right. Don't forget to multiply by the mass though, okay? Force of gravity is not 9.81. Force of gravity is mass times 9.81. All right. 600A equals 5.2 times 10 to the 3. Subtract, I think that works out to be 5, is it 588.5, 5,886. Okay, thank you. So 5,200 minus 5,886, which gives me, I think, negative 686. Right? We're good there, guys? And then, of course, we take this over by dividing, and we get A is equal to negative 686 divided by 600, or negative 1.14 meters per second squared. They've said it's 1.14 down. I've said it's negative 1.14, same thing, right? How is this question any different than the other ones we've done? Than your quiz question yesterday? It isn't, right? It isn't. Once you've got your free body diagram drawn, it isn't any different. F net is equal to the sum of the forces. Put your stuff in, solve for whatever you're looking for. 2 is a little bit harder. Okay, it is a little bit harder. Now, it's not harder to set up. It's not harder to get almost full marks for on a test, but it is harder to get full marks for on a test. It's harder to finish it off. Question number 2 says, an electric chain hoist in a garage exerts a force upward on an engine. There's an acceleration upward. What's the mass of the engine? Here's the engine. Here's the chain pulling upward. We're going to call that Fn again, and its value is 2.85 times 10 to the 3. Okay, it's like the elevator being pulled upwards, right? We know there's a force of gravity acting down. You guys notice that I drew the force of gravity quite a bit smaller? Quite a bit smaller than the normal force? Everybody know why I did that? Cody, do you know why I drew the force of gravity smaller than the normal force here?
Because the normal force is bigger than gravity.
How do you know the normal force is bigger than gravity? You're right, by the way. He said the normal force is bigger than gravity. He's right. But why? How do we know the normal force is bigger than gravity? How do we know that, though? Yeah. It's accelerating upward. If it's accelerating upward, the upward force has to be bigger than the downward force. If it was accelerating downward, gravity would be bigger. So, we know what to do here, right? Okay, no surprise here. Nothing complicated or confusing here. The net force is the sum of the forces. That's Fn plus Fg, same as it was in the last question, in fact. Next step, we know what to do. It's always the same. Ma is equal to the sum of the forces. We don't know the mass, do we? We don't. But we know the acceleration. It said it was 1.5 upwards, so plug that in. Fn was 2.85 times 10 to the 3. Bless you. Bless you. And the force of gravity is, what's the force of gravity? No, not 9.81, but you're close. No, you're getting closer. Times mass, good. It's mass times negative 9.81, right? Acceleration is negative 9.81. Acceleration due to gravity, that is. The force of gravity is mass times that. But unfortunately, we don't know what the value of the mass is. Okay, so how do we solve for m here? It's in 2 places. The good news is it's the same unknown. It's not 2 different unknowns. It's not like having x and y in the same equation. But it's still in 2 places. We got to combine like terms. Combine the m's. But let me lead you to this, okay? I got a question for somebody. Who thinks they can handle a really challenging question right now? Nobody? Nobody wants to go out on a limb here? Ethan? Good, Ethan, thank you. Ethan, what's 1 plus 2? Oh, look at that. See, you guys should have volunteered. It wasn't so bad after all, right? 1 plus 2 is equal to 3. Agree? Okay, Ethan, what's 1x plus 2x? You guys agree with that? Look, see, you're as smart as Ethan. Ethan volunteered to do the really hard questions. You guys could have done them too. 1x plus 2x is equal to 3x. All right, what's 1m plus 2m? 3m? Everybody with me so far? All right, what's 1.5m plus 9.81m? Whatever 1.5 plus 9.81 is, right? It's at 10.9, 10.81, 11.31. Does that make sense? All right, so take this over by adding. And we get 1.5m plus 9.81m equals 11.31m. And then we just simply solve for m, divide 2.85 times 10 to the 3 by 11.31. And when we do that, we should get the answer that's in the book there of 252 kilograms. Is that okay? Does that make sense? How many people got that math? Okay, good. Good. That's good. Okay, right now, it doesn't seem so bad after I've gone through it, right? But before I do that, that's tricky. Okay, that's tricky. You guys haven't done that before in Physics 20, something like that. That's a bit tricky. Okay, you do that on a quiz. Say, let's say that was a quiz today, and you end up getting this far. I'd be pretty happy with that. Okay, but the reality is we can all get that far as far as the red circle, right? Past that, we got to know a little bit more math. We got to be able to think on our feet there with our mathematics. Okay, but the physics will get us to the red circle, and we all should be at that point there right now where we can get to the red circle. Okay. All right. So nothing real new today, but we're just going to do some problems. I'm going to give you an example right now that's going to look quite a bit different than what we did yesterday. But you're going to see in a moment that it's the same thing. Everything we do today, even if it looks a little bit different, is going to be the same thing as what we did yesterday. This one says two objects A and B are connected by a light rope over a light frictionless pulley. A mass of 25 kilograms. A has a mass of 25 kilograms. B has a mass of 35 kilograms. We determine the motion of each object once the objects are released. What we're really looking there for there is the acceleration. And the good news is, even though we're asked to find the acceleration of each object, they move together, right? If you're in your car and your car accelerates at 2 meters per second squared, what's your acceleration? 2 meters per second squared. If your car is towing a trailer, what's the acceleration of the trailer? 2 meters per second squared. So if object A accelerates at 2, then object B will accelerate at 2 as well. So even though we're looking for the acceleration of both of them, if we find the acceleration of one of them, we got the acceleration of the other one, right? Now, we got to draw a free body diagram, right? That's what we do. There's more than one force acting on this system. There's a force of gravity acting down on the 25. I'll call that FG1. And there's a force of gravity acting down on the 35, which I'll draw bigger. How come? Why did I draw FG2 bigger? It's heavier. Good. Bigger force of gravity because it's heavier. Good. Good. All right. That's it. There is a tension in between there, but that would be an internal force, right? That's not contributing to the motion of the system. That's just keeping the system together. That's like saying, remember the other day we were talking about the semi-trailer, the tractor with the hitch. Right? The hitch provides a force, but it's an internal force. It doesn't contribute to the motion of the system. It just ties the system together. This rope is like the hitch, so it's an internal force here. All right, so what do? We know what to do next, right? F net is equal to the sum of the forces. You know what? Just drop your pens on this right now. Don't copy this yet. Okay, I promise I'll give you time to copy this. Thank you for those of you who are diligent and trying to copy right now. That's good. But just wait 1 second before you do copy, okay? You'll see why in a minute. We're going to say F net is equal to the sum of the forces. That's going to be FG1 plus FG2. What's next? Miles, what's next? No, not yet. F net is mass times acceleration. So let's say MA is equal to FG1 plus FG2. Mass is, what mass would we use here? 25, 35, or 60? Somebody said it. 60, yeah. It's the whole thing that's accelerating, right? If you're analyzing the motion of your car, do you include the mass of you inside the car when you're analyzing that car? Of course you do, right? Because it's part of it, right? It's included with the system. Both of these masses are included with the system. 60 kilograms is our mass. FG1 is, what's FG1? Yeah. Good, 25 times 9.81. Not just 9.81, right? 25 times 9.81. Now, we got to make that negative, right, because it's down? Yeah, you did, yeah. So whether we put that in front of the 9.81 or in front of the 25 doesn't really matter, right? What's the other force of gravity? It's 35 times 9.81 or 35 times negative 9.81? Right? Who agrees with that? Okay, trick question, because you're wrong. But I kind of tricked you into that. I kind of led you down that path. What's wrong with this? Yeah. Well, force of gravity is down on both of them. One will go down and one will go up as far as the acceleration goes. Okay, but the force of gravity is down on both of them. Right? Gravity doesn't pull up ever. Notice? You're kind of right, but you're kind of wrong. You're right, but for the wrong reason. We do have to make these opposite signs. One's positive, one's negative, but not because one will go up and one will go down, but because the force of gravity, even though it pulls down on both of them, the force of gravity on the first one is opposing the force of gravity on the second one. Does that make sense? The force of gravity on the 25 is trying to pull this system this way. The force of gravity on the 35 is trying to pull it this way. Right? So 35 trying to pull it this way, 25 trying to pull it this way. They oppose each other, right? It's like putting a rope around a tree. You grab one end of the rope, you grab the other end of the rope, and you both pull. You're not helping each other, right? You're opposing each other, even though you're both pulling backwards, right? We've always made forces opposite in sign if they're opposite in direction. These forces aren't opposite in direction, but they are opposing each other. We now have to think about making forces opposite in sign, not only when they're opposite direction, but when they're opposing each other, like this. So one of these is going to be negative, and one of these is going to be positive. Doesn't really matter which one is which, but one of them is going to be negative, one is going to be positive. I'll tell you what, here's what I like to do. It just reminds me of that. If I take this 25 and I kind of stretch it out like this, and the 35 and I stretch it out like this, then I'm going to have a situation where I got a 25 and a 35 with FG2 pulling that way and FG1 pulling this way. Does that make sense? I kind of stretched it out. That reminds me that one of them is negative and one of them is positive. Gravity isn't really acting left and right. Gravity is acting down in both cases, but it reminds me that they're opposing each other. So according to this diagram, I'm probably going to make this one this one negative and this one positive now. Even though it's downward, I'm going to make it positive. Is that okay? A little bit of a twist to this question. Besides that, exact same question as we've had. 60 times A, the right side will be, do the math there, and it's going to work out to be a positive 98.1. And A will be 98 divided by 60, which is 1.6 meters per second squared. Right? That's a doable question, right? Do you see where we've come here, though? As we've come from problems involving, somebody pulls to the right, somebody pulls to the left, to elevator problems, to pulley problems, And we realize they're all just the same thing, right? They're all just draw free body diagram, F net is the sum of the forces. We just have to, on these ones, be a little careful of the direction, that's all. All right, now you can copy that down. Okay, this one says a 20 kilogram truck tire, object A is lying on a horizontal frictionless surface. Hey, that's good news that it's frictionless. That makes life a little bit easier for me. The tire is attached to 2 light ropes that pass over light frictionless pulleys. You got another pail here, 8 kilograms, another pail, 6 kilograms. We want to find the magnitude of the acceleration. Okay, we can draw the free body diagram right here if we want, but I don't like to do that. I like to straighten it out like I said last time. So let's do that. If we straighten it out, then pail B would be over here with a force of gravity. We'll call it FB, the force of gravity on object B pulling to the left. Does gravity really pull to the left? Of course not. Of course not. It pulls down. But because this force and this force are both pulling down but opposing each other, I'm going to draw it a little bit differently here. What else do we got here? If I want to straighten it out like I have right here, is there anything else that I got? Yep. Yeah, there's an FC right here, right? Which is really the force of gravity acting on C. Technically, there's also gravity and the normal force acting on object A, right? But what do we know about those two forces? They cancel. So I'm not even going to draw them in here because I think it's just going to get a little bit confusing if I do that. All right. F net is equal to the sum of the forces. Nothing new here, right? FB plus FC. F net is M times A. What mass do I use here? A is 20 kilograms, B is 8 kilograms, and C is 6 kilograms. What mass do I use there? All of them, good. So it's 8 plus 20 plus 6 is 34. FB, the force of gravity on object B, Thodas, is what? The force of gravity acting on this guy right there. Good. What mass do I use? 8, 20, or 6, or some kind of combination. What mass do I use for the force of gravity on B? Sorry? Yes, good. 8 times 9.81, right? But we're going to make it negative because it's to the left. It's really down, but we're saying it's to the left here, right? My next force is the force on C, which is, Cassie, that's the force of gravity on C, right? How do I find the force of gravity acting on object C? Let me give her a hand there. 6 times 9.81. Positive or negative? Why is it positive? Yeah, I've got it drawn to the right here, right? It opposes FB. That makes sense, Cassie? Force of gravity acting on object C is mass times gravity. Mass of object C times 9.81. All right, what do we got here? 34 equals negative 19.62. It's going to be 0.6 or so. Good. So that means really, strictly speaking, object pail B accelerates downward at 0.58 and pail C accelerates upward at 0.58, right? The system goes to the left. Okay. Leave the negative, it's fine. Okay, even if I ask for the acceleration of both of them, it's fine. All right, I want you to have a look at page 157, questions 1 and 2 here, please. Okay, we're having a look at question number 2 here. It says if the tire in example 3.11 is replaced by a car tire of mass 15 kilograms, so what do we got? 15 kilograms here. What's the acceleration of each object? Well, we still have pail B over here, and we still have pail C over here. What was the mass of pail B in the example problem? 8. And then I think the other one was 6, wasn't it? Thank you. If we straighten it out like this, like we have it drawn on the board right now, we still have two forces acting, but those two forces are acting in kind of gravity, kind of acting in two wacky directions here. We got force of gravity acting on object B, it's going to be to the left, and the force of gravity acting on object C, it's going to be to the right. Tell me when to stop drawing this, okay? I'm going to draw it, you say stop when I've got it long enough, okay? No, maybe not quite. All right. Why did you tell me to stop just a little bit before I got to the length of the FB? Why should it be shorter? Yep. Right. It's gravity, and FB is heavier than object C. So therefore, the force is going to be bigger than on object C. Hey, we know what to do here, right? F net is equal to the sum of the forces. It's going to be FB plus FC. These are both forces of gravity, right? I'm just naming them something different because it's convenient to name them something different. Next step. Caitlin, what's the next step? Good. F net is M times A. That's equal to FB plus FC as well. What mass do I use here? 8, 15, 6, or some kind of combination of that, Nolan? 8, 15, or 6? What kind of combination for that mass right there? What are my options here? 8, do I use 8 kilograms, 15 kilograms, 6 kilograms, or the combination of them would be 29, I guess? So 8, 15, 6, or 29? 29, good. Now FB it's a force of gravity acting on it, right? So it's going to be, Katie? Good. 8 times negative 9.81. And FC is also gravity. We're going to make that 6 times 9.81, right? Negative? Positive because it's drawn to the right. 29A equals, that's going to be negative 19.62. Now we got to divide here. 19.62 divided by 29 is about 2/3, about 0.65, 67, 0.68. Negative 0.68, right? Good. It's coming, right? Look at where we are right now. And everybody kind of gets this or completely gets this. Look at where we are right now compared to where we were 2 months ago. 2 months ago, when I'm telling you, if the distance traveled is 20 meters and the time taken was 5 seconds, what's the speed? And look at where we are right now. Seriously. We've come a long way since just using V equals D over T, right? And sometimes finding that a little bit challenging. Okay, got some more work for you to do. Got a worksheet to hand out, and you're going to work on a number of questions on that worksheet. And that's going to be your homework for tonight.